Hello everyone, welcome back to Cambridge Group. In the last video, we talked about the concept of HCF and LCM, and we also learned one property that if we have been given two numbers A and B, then there was a property that multiplication of these two numbers is equal to the multiplication of their HCF and LCM. In this video, we will do some questions based on the HCF and LCM concepts, right? So without wasting any time, let us see the first example number 4 of the whole lecture series on your screen. So it says that the HCF of 140 and x is 20. So we have been given two numbers. One is 140, second is unknown, which is x. The HCF is given as 20. Similarly, LCM is given as 420. We need to find out the value of the second unknown number. So, as I said, the property that we will use here is A into B, meaning multiplication of two given numbers is equal to HCF multiplied by the LCM of given two numbers A and B. So here, A first number is 140, let us say, and second number B I will take as x. This is equal to HCF, which is 20, and LCM of the given two numbers is 420. Right? On simplifying, I get x as 20 multiplied by 420 over 140. Okay, so 0 gets cancelled with this. 42 goes with 14 3 times. So I get x value as 60. And this is your answer. Okay, nice and easy, very simple, just concept based, right? Property based, not the concept based. Let us switch to the next example. Example number 5 says, let s and t be two natural numbers, right, such that they are written as 2 raised to power 4 multiplied by 3 into 7 square, and t is written like this. We need to find out the LCM of and HCF of the given two numbers, right? Now, we have learned that whenever the numbers are written as a product of its prime factors, not just the prime factors but the exponents of these prime factors, then HCF is equal to the multiplication of common prime factors having least exponent. And in order to find out the LCM, we will say multiplication of the prime factors which are common with their highest exponent. And since, as you must have realized here, that s is already written as a product of prime factors, which is 2 raised to power 4 into 3 into 7 square, and t is written as 2 multiplied by 5 cube into 7 cube, right? Now right here, in order to find out the LCM, we need to include those factors also which are not common. Meaning is, as we can see in s and t, 2 is there in s, 2 is there in t, so no need to add 2 raised to power 0. But in the second prime factor, which is 3, this is not in t, so we will include this as 3 raised to power 0. Okay, just watch my previous video in which I have introduced why this 3 raised to power 0 has to be included. Actually, this is, of course, it is obviously 3 raised to power 0, which is 1. So any number multiplied by 1 will remain same. So we can write this 1 as 3 raised to power 0, just to include the common factors. Okay, so we just need to find out the highest and lowest exponent. And again, since 5 is not there in s but it is in t, so in s we will write, or just to include 5, we will write this as 5 raised to power 0, right? So now, as you can see here, that both in s and t we have all the 4 prime numbers written as some exponent. So 2 raised to power 4 into 3, so we have 2 here, 3, 5 and 7. Here also we have 2, 3, 5 and 7. Now we have all the common factors. We just need to find out the least and maximum exponents. Okay, so for finding out HCF, just remember the concept. It was that we need to find out the common factors. So we have 2 raised to power 4 here, 2 here. So we just need to take the least exponent. So we will just take 2 raised to power 1. Right? Out of this 4 and 1, we have 1 as the least exponent. Then we switch to 3. Right? So 3 raised to power 1 is there, 3 raised to power 0 is there. So we will include 3 raised to power 0, which is in fact 1. Okay? So no need to include this 3, or you can just write this as 3 raised to power 0, just to avoid the confusion. And then next exponent common is 5. Again, least exponent we will take 5 raised to power 0. And the last prime factor is 7. Out of 7 cube and 7 square, we will just take 7 square. Right? So here we have 7 square is 49 into 2 is 98. So HCF of given two numbers is 98. What about LCM? So LCM, we will take the highest exponent. So this time instead of 2 raised to power 1, we will take 2 raised to power 4. Then instead of 3 raised to power 0, we will take 3 raised to power 1. Again 5 raised to power 1, and this time we will take 7 cube. Okay, so this will come out to be, after calculation, 205800. Right? So again, just concept based, that how you will find out the HCF and LCM if certain numbers are written as a product of prime factors, just to take out the least and maximum exponent. Okay, let us switch to next question. I would say that you just pause the video for each question, okay, and do by yourself. This is again a very good question, again based on the same exponent concept of LCM and HCF. So it says that there is an integer x which is written as a product of its prime factors like this, where a and b are unknown. Another integer y written as a product of its prime factor like this. This time the HCF of x and y is given and LCM is also given. We need to find out this time what are the numbers. So in the previous question, we have been given numbers. We were finding HCF and LCM. This time question is reverse in the sense that this time HCF and LCM is given. We need to find out some unknowns in the number. Okay, fine. Now just write this x as, since x is written as some prime factors, product of prime factors. So if x is a square into 7 raised to power b plus 2, right? So it is inherent that this a is I would say is a natural number, because since we are dealing with prime factors, it is already saying in the question, so prime factors cannot be negative. Prime factors are basically natural numbers. One thing is this, and similarly we can say about b also, that since this exponent cannot be a fraction as far as exponent of prime factors is concerned. Okay, so 7 raised to power b plus 2, here b is also a natural number. So both a and b are natural numbers. Okay, I should write are natural numbers. Fine. So writing y as a cube into 7 square. Now HCF is given as 1225. So in terms of a and b, how I can write HCF? So as you can see, there are no other factors other than a and 7 in both x and y. So no need to include some b raised to power 0 or any other prime factor. So for HCF, we have to take the common factor, which is a square and a cube. Least exponent is of a square, so we pick a square. And out of 7 square and 7 raised to power b plus 2, I would say is 7 raised to power b plus 2 is greater than 7 square, because b is a natural number, meaning its value should be greater than or equal to 1. Having said that, this value becomes automatically greater than 7 square. So I will take the least exponent as 7 square. So we have here HCF as 49a square, and now this 49a square value of HCF is given as 1225. So 1225. On simplifying this, I should write here. On simplifying this, a square is 1225 over 49. I will get a square value as 25. Okay, and a is not just plus 5. Please be very conscious here that it is rather a plus minus 5. Whenever there is some second degree equation and we need to take the square root, always put plus minus outside the square root, right? Now we will take, or we have to reject one value depending upon the condition given in the question. Meaning is, since a is a natural number, so we cannot take minus 5 as the value of a. Had it been no condition given in the question, then we could have taken this a as both plus minus 5. But since here a has to be a natural number, so we will just take the value of a as just 5. Fine. Now for LCM of x and y, so LCM is equal to, we will take this time the highest exponent. So we take a cube into 7 raised to power b plus 2 this time, right? And this is equal to, the value of HCF is 42875. This is given. Okay. Now again we have two variables here, but this time we have find out the value of a as 5. So putting a as 5 in this, so 5 cube into this 7 raised to power b plus 2 can be written as 7 raised to power b into 49. Although laws of exponent is the next topic, next topic we will see. But for now, I think you know that 7 raised to power b plus 2 can be written as 7 raised to power b into 7 square, which is 49. So this is equal to 42875. So this is 7 raised to power b is equal to 42875 over 49 into 5 cube is 125. Right? On simplifying this, I will get 7 raised to power b is equal to just 7. Now, if we have a variable in the exponent, and if the bases are same, then exponent has to be same. And this condition is only true if base is not equal to 1. Okay? If we are saying if bases are equal on both the sides, then exponents will be equal to each other. This is only true if base is not equal to 1. Right? So here base is 7. So we can compare the exponent, that in this case b, we can compare the exponent like this. So b is equal to 1. Right? Now having known the value of a and b, the question was asking about find the value of x and y. Right? So x was written as a square into 7 raised to power b plus 2, putting back the value of a and b. This is a square, meaning 25, into 7 raised to power b plus 2, meaning 1 plus 2 is 3. So this is whatever is the value, you can find out on your own. Similarly, putting the value of a and b in y, this will be a cube. So 125 into 7 square is 49. Okay. So these will be the values of x and y. So that's it as far as HCF and LCM is concerned. Let us do a small topic which is based on order of operations, which is our next topic, right? I think all of you know the concept of BIDMAS. What BIDMAS stands for is that whenever we see any different types of arithmetic operation within a single question, so what is the order of operation that we need to what is the order we need to obey or we need to follow, right? So this is, as you can see in this diagram, The first step is to find out the brackets, not finding out the brackets, but to solve the brackets. So B stands for brackets in BIDMAS. So whenever there is any bracket in any arithmetic number or question or expression, we need to first solve whatever is inside the bracket, right? Then comes indices, meaning the exponents. Okay, something which is written, let us say 2 into 3 cube plus 5 and so on, right? So we will first, since there are no brackets in this, so again the next step will be to solve the indices. So instead of writing 2 into something, so we will first follow the step of writing 3 cube as 27. Okay, then next comes the division. So D stands for division in BIDMAS, M stands for multiplication, and A and S both stand for addition and subtraction. Okay, so these are the steps that we will follow whenever there is any combination of arithmetic operations in any expression. Fine. Let us do one question based on order of operation, and we are not doing deeper into this because BIDMAS you have been knowing, I suppose, for the last 3 and 4 years. So there is no new thing in BIDMAS. So for example, evaluate the following without using the calculator. So as you can see here, we have brackets here, we have division here, we have multiplication also here, right? So the first step is to arrive at bracket. So here we can see the brackets is this. That means we will go inside the bracket. Once we are inside the bracket, we again can see that there are two operators. One is addition and second is multiplication. So what is the order of operation that will follow? We will first solve the multiplication part, this. So we will write 3 upon 4 divided by 2 upon 5 minus 1 upon 2 plus this time. What is the value of this? I think you know that in case of multiplication of fractions, numerator gets multiplied with numerator and denominator with denominator. So this is 9 by 10. So what is the value which is inside the bracket? Minus 1 upon 2 plus 9 upon 10 is 5 plus 9 is 14 over 10. This is 14 over 10. Okay, I'm writing like this. Now the next order of operation comes the division, right? We have solved the bracket, there are no indices. So next is D, which is division. So we will now solve 3 by 4 divided by 2 by 5. You must be knowing how to deal with the division of fractions. That first fraction will remain as it is, and this division sign changes to multiplication, and the second fraction we need to reciprocate. That means this will be equal to 5 by 2, right? And minus 14 over 10. If we can simplify this 14 by 10 as common factor is 2, so we can write this as 7 by 5. Just to simplify the things. Okay, so I'm writing this as 7 by 5. This is 7 over 5. So this simplifies to 15 by 8 minus 7 over 5. Okay, now how to deal with unlike fractions? Dealing unlike fraction meaning how to add and subtract unlike fraction. We need to make both the fractions as like fractions by finding out the LCM. So converting this LCM of 8 and 5 is 40. So we will multiply this by 5 and we will multiply 7 by 8. So this is 15 into 5 minus 7 into 8 over 40. This comes out to be 75 minus 56 over 40. Meaning is this is 19 over 40. Okay, so this is your final answer. Okay, of course, not a new thing for you, I suppose. So that's all for today. I'll be right back with the next video with some more new topic in chapter number. Okay, till then, bye bye. Thank you.